Hello, good morning to all. Can you hear me?
Yes, we can hear. Good morning.
A very good morning, David, Miracle, Nayantara, Reena, everyone. Good morning. Everyone turn on a camera so that we can start our class. Yes, very good. So, Miracle, good morning. How are you? How was your camp?
So,
It was good.
yeah,
So, you enjoyed there? It was a youth camp, no?
yeah, sir. 3 days camp.
Where? Like near your place only, or it's
Yeah,
some out?
Pundi. A place called Pundi.
Oh, okay, okay. Wow, that's great. That's awesome. So you saw the videos, previous videos?
Uh, yeah, I will watch today because I didn't got time.
Okay, okay. It means you didn't watch, no?
Yeah,
Okay, okay, okay. Okay, okay, Agatha, we were doing that chapter, no? And it was
Yeah,
about to complete.
yeah. I mean arithmetic progression, chapter 7.
Yeah. Okay, good morning. Good morning, David, Reena. Turn on the camera, please, so that we can start the class. Okay. So we were doing some of an AP and I gave you some questions. Mummy? Oh, mummy! We were doing some of an AP. Okay, now we'll do some questions. Hmm. Okay, now we will do this type of question. So, basically, this question is find the sum of an all natural number. We have to find the sum. Remember this of all natural number which are divisible by 7. Okay, which are divisible by 7. We have to find all the sum of that natural number. Okay. So what is the formula for that? Like we know the sum we have to find. And which one is the first number which is divisible by 7? First number which is divisible by 7? Tell me quickly. First number which is divisible by 7. 7 itself? Because it's starting from 7, no?
14.
Okay, yeah. So the first number is 7, then it will be 14, and then Reena, what will be the next number?
21.
21, and go on. Till 1000 we have to write. So we will not write each number till 1000. Okay. So what we will do, we will find out the last number that is divisible by 7. Are you getting this? No. Say yes or no. So what the question is saying, we have to find the sum of an all the natural number which is divisible, which are in between 1 to 1000. Okay. So last number should be 1000, not more than 1000. So can you tell me the number which is divisible by 7, the last number? Anybody? Like if I will check 999, if I will check 999, and if I will divide it by 7, 7 1 ja 7, and then 2 will be there, then 29 it will become 7 4 ja 28, then 1 will be there, and 19 it will become 7 2 ja 40. So obviously we have a remainder of 5. So this is not fully divisible. 999 means 999. It's not fully divisible. So what will be the number? It will be 994. Correct. Because this is the 5 as a remainder. If I will subtract it from the main dividend, I will get the number. Are you getting this, Agatha, Miracle? So this will be the last number. So now we have to find the value of n. Like we got the AP. Yes, guys, we got the AP. This is an AP. This is the last number. Can you find the value of n? Tell it to me. Can you find it out, Reena? How will you find the value of n? With which formula?
S S is equal to n by
N by 2.
n by 2 um
Yeah, you can see and tell. You can check from your notebook and tell. S is equals to n by 2 into 2a plus
n minus 1
into
D.
d. But that in that part, we have the value of a. What is the a? Can you tell me, Reena? A is the first term, which is
7.
7. And what is d? D is the difference, which is 14 minus 7, which is again 7.
7.
But do you have n? Do you have
9.
n?
Yeah,
That is, yeah. What is the n? Tell me.
994.
That is the an.
Okay,
N,
1000.
no. See, n is how many numbers are there? 1, 2, 3, 4, 5, 6, like this. What is the place of this? We don't know that.
Okay.
So first you have to find the value of n. How will you find it out? Tell me. Is it? Can you use this formula? An is equals to a plus n minus 1 into d.
Mm.
Why? Why you will use this? Because this is the number at that position, which is called as an. Yes,
Okay.
you will put this. You a we have, d we have. Can you find the value of n by this formula?
Yeah.
Got it, Reena? No, you didn't get
Yes,
it.
I got it.
Okay, so this is the formula. First, we will use to get the value of n, and then we will use your formula. Okay, do it quickly and tell me the answer. Okay, now we'll come to miracle. Miracle, this is an AP chapter. We are about to complete this chapter. I believe that we'll complete this chapter by today. So, for your revision, everyone do your part. Do solve this question, and I'm just explaining this thing to Miracle. Okay. Now, Miracle, this is an AP. Now, what is an AP? AP is the number of series in which the common difference is same. In which the common difference is same. For example, 7, 14, 21. If this will go on, so what will be the next number after 21? Can you tell me?
28.
28. How you got it? Because you saw that the difference between them is 7. So this is also 7, this is also 7. The next number which will come will also have 7, so it will become 28. It's gonna be look like this. So this is the basically the AP. This is called as AP, in which the common difference is same. Now we have some terms. Okay, the first, like A is called as first term. Okay, A is called as what? First term. D is basically called as difference. D is basically called as difference. N is called as nth position. N is called as what? Nth position means number. Like if I will say, what is the number at sixth position? So what is the value of n? 6. So what is the number at second position? Second position is 14. So basically, nth is the place at which we are asking. Sixth position, eighth position, 28th position, like that. And an is number of nth position. So if I will say what is the number at second position, so what you will say? What you will say? No,
14.
here 14. Yeah. So number at 14. So what is the value of that? In that case, n is equals to 2 because I asked for the second position, and an value will be 14. This is the summary what we learned. Okay. So now in this question, the question is saying that the AP is there, but the thing is, we don't have the value of n. Like how many numbers are there? One, two. Oh, sorry. How many numbers are there? 1, 2, 3, 4, 5, 6. So first we are calculating the value of n. We have A, we have D. Just now I wrote. Okay. Now we have to find the value of n. We have the an also, the last term. So that we can get total numbers of, so that we can get the value of n. Got it? Now you got it? Miracle? No. Ask me if you have any doubt, beta. Please ask me.
Got it, sir. This time we're gonna write it.
You want to write it?
Yeah. We're gonna do it.
Okay. So this is yours. Okay, you write it down.
Yeah.
Now, Reena, yes.
Are
Who
you,
says?
are you
Somebody
going to
said.
finish this chapter?
Yeah, by today, I guess we'll complete this chapter.
Small chapter?
Sorry?
Is it small chapter?
Yeah, it's very small chapter. Yeah, Reena, you got the value of n. Now you write it down, Miracle. Yes, Reena.
I got the value of n as 142.
So you got a, like, yes, a plus n minus 1 into d. So an is 994 is equals to 7 plus
n
n
minus 1
minus 1
into 7.
into, yes. So it will become 994 is equals to 7
plus
plus,
7 n minus 1 into n minus 1.
yeah,
994 is equal to 7 plus 7 n minus 7.
like this. Is it like this?
Yes, that's what I've written.
Okay.
Yeah.
So
And then
this and this will basically, yeah,
994 is equal to
7n.
7n. N is equal to 994 divided by 7. N is
No,
equal to,
first this 7 will go that side, no?
yeah,
So it will become 994 plus 7
yeah.
is equals to 7n. So it become what I wrote. Pair.
No. Like the 994 is equal to 7n, and then next step n is equal to
Yeah.
994 divided by 7. Right?
Yes. Yes. You are correct.
And then n is equal to 142. 994 divided by 7.
Is equals to n, and then n is equals to 142.
So I got the answer.
Yes. Now, what is the value of s? So Miracle, we have one more formula to find the sum. Now, what is sum? Sum means adding 7, 14, 21, all this, like 7 plus 21 plus, like whatever the number on the AP, we are adding it. So we have one more formula, which is equals to s is equals to n by 2 into 2a plus n minus 1 into d. This is the formula. Got it? So, Reena, you got the answer, Nayantara? Okay. So we'll. Okay. So basically, what is the value of n? N is 142 divided by 2 is equals to 2 into a, which is 7, plus n minus 1, which is 142 minus 1 into d. D is also 7. So if I will cut it, I will get 71. S is equals to 71 into 14 plus 141 into 7. Miracle, you got it? What I did? I just put the value of A, D, and N on the place. So S is equals to 71, 14, and then it will become 9, 8, 7. Then S is equals to 71, and then if you will add it, you will get 1000. 1001. Is it this? Yes, this one only. So S is equals to, you have to multiply it and you have to tell me the answer. Got it? Nayantara, Abraham. Abraham, good morning. Can you hear me, Abraham? Yes, he's not there. Rina, you got the answer?
Not yet.
Anybody has any doubt, please ask me, guys.
So is my answer correct?
Let me check it out. Just give me a second. Yeah. Where's your answer? Yes, correct. Correct, David. Yeah, who didn't understand this concept? Please ask me, beta.
Multiply 71 into
1001. Yeah. Yes. Now you guys do this question. Rina, can you do this question, which is on the board? Or you have any doubt?
Which question? I can't see.
You can't see this?
I mean the question.
This one. Can you see the mark?
Yeah.
This one. Abraham, are you there? Can you hear me, beta? Yes, Miracle. How will you do this? you just help me. What you got it, just tell me. So first we have to find the sum. Sum means we have to use the S wala formula. Okay. All the natural numbers up to 100 only, which are divisible by 3. So tell me the first number which is divisible by 3.
3,
Then next number will be
6, then 8,
then 9. Now you
12.
don't have to write till 100. Okay. So what is the last number that is divisible by 3? Like 100 is not divisible, okay, by 3. Then we'll come to 99. Is it divisible by 3?
Yeah,
So what is the last number will be then? 99.
99.
Now what this things is like, we know the value of A, which is 3. Yes. We have the
Yeah.
value of what? We have the value of D. What is the value of D? D is the common difference between them.
D is 6.
No, common difference between the numbers. Like, what is the common difference between them?
3.
Yeah, so D is also 3 in this case. Okay. Now, we don't have the value of N because, like, how many terms are there? We don't know, no? Like, first, second, third, and like that. What place? What is the place of that? We don't know. So, we have the last number. The last number is AN, which is 99. Now, can you find the value of A? Can you find the value of N? With which formula? With the general formula. Got it?
Yeah. An
So
equals
what
to
is
A plus N minus 1.
into D? Now what is the AN?
An is 99.
So I will put 99 is equals to what is A?
A is 3. 3.
So I will just multiply it. So I will get 3 plus 3n minus 3. This and this will cut. So 99 is equals to 3n.
N.
So what is the value of n? 33.
3. No, yeah, 3. 46.
Okay. So if we have to find a sum, what is the formula for the sum? Sum is equals to n by 2
2. N by 2. 2A plus N minus 1 into D.
n minus 1 into D. Got it? Okay. So now we have to put the values. Like we have the value of n, we have the value of A, we have the value of D. Just put it. Can you solve it and tell me the answer? Abraham, are you with me? Did you understand the concept or do you want me to explain it again?
So can you explain it once more? So I just went to the
Yes. Okay. No problem in that. So in this question,
I have,
yes, Miracle.
I have a question. The previous question.
Previous question. Okay, let me make Abraham understand this, then we'll go to the previous one. Okay. Yes, Abraham. So what we did, can you read this question, Abraham?
Find the sum of all natural numbers up to 100 which are divisible by 3.
Yeah, which are divisible by 3. We have to find all the sum till up to 100, which is divisible by 3. So this is an AP 3, 9, 6, and 9 because the first number is 3, which is divisible by 3. Then the next number is 6. Then next number is 9, and it will go till 99 because we have to find only up to 100. Got it? Okay. Now, what is the first number? This is the first number, which is 3. What is the value of D? D is the A2 minus A. Means for the first, like second term minus first term, which is also 3 in this case. Now, we don't have the value of N. Like how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8. How many numbers are there? We don't know. Abraham got it? Now, the last term is AN is equal to 99. So when I put, like we use this formula before also, in which I put the value of AN as 99, A as 3, D as 3, and then I put it, I got the value of N as 33. Means there are 33 numbers are there. 1, 2, 3, 4 like this, 33 numbers are there. Okay. Now we will use the sum formula to get the sum. Like N we know 33, A we know 3, N we know 33, and D we know 3. Now you have to put it and you have to solve it to get the sum till 99. Got it? No.
So I think so.
Yeah. If you have any doubt, ask me, okay? Yes, Miracle. What do you have doubt in the previous one?
Like in the
Yeah.
yeah. In the second, the S equals to N by 2 in that one. S equals to 71, 14 plus 141 into 7. Like first you wrote 142 minus 1. Okay. Yeah, I got it.
Then become 141. Yes, Abraham, ask me what doubt you have. Abraham, you got it? No.
Okay, so I think I understood.
Oh, okay.
Sir,
Mm-hmm.
is S 1683?
एक minute. What's the answer? Yes, you got 1000. 1600 and
83?
no. No. You are very near to that. David, no, it's not. No. It's not that. Let me check on let me solve it. If you go to it. I am also getting the same answer. Why? Is the book answer is wrong? Like 50, 33 fives up. I guess book answer is wrong. I'm also getting the same. Yes. Who didn't understand? Ask me. Abraham, David, got it? Say yes or no.
Yes, sir.
Okay.
So the
Now
answer
we'll.
is correct, right?
Yeah. Nayantara, you got the answer? Reena? Now, this is the important question. Put a star mark on it. Because this one is little not difficult, I will say, but it's a little bit tricky question. Okay. So I will solve this for you guys. Now, this question says that who will read this? Okay. Nayantara will read this. Yes, Nayantara, read this.
So the sum of three consecutive terms in an AP is 21 and the product is 231. Find the third term of the AP.
Find the three terms of an AP. So basically, we don't know the APs and we don't know the three terms of an AP. Now, whenever you get these types of question, only the single way is there to get the answer. Okay. So we know that the first term of an AP. What is the first term of an AP? It's A. Yes. Like I told you before also, what is the first term of an AP? The first term of an AP is A. What is the second term of an AP? It's A2. Then third term of an AP, it's A3. Then fourth term of an AP, it's A4. So basically, this is how we wrote AP. Are you getting this? Now, the first term is basically the first term. This is the first term.
So
Okay.
I had
Yeah.
I had a question. Since it's sum of any three consecutive terms of an, so is the first three terms, the sum of that is equal to 21, right?
Yeah. So it's not only first three terms which is equal to 21. It can be any number. So we'll check
Okay.
it out. We'll check it out. So we know that the first term here it is A. Now what is the second term? Second term is A2. Yes or no? Now, like we know that difference is D. Like each term has a difference, same difference, which is D. Okay. So can I write A2 as A plus D? If I will write it down, is there any problem in that? I wrote A2 as A plus D. Do you know why? Because like A2 means this is the A2 means the A plus D, like first term plus D. Are you getting this? Reena, are you with me?
Yes, sir.
Did you understand this? No. Please ask me if you have any doubt.
No doubt, sir.
Hmm? So what will be the second term then? What will be the third term? What will be third term in respect of first term? So it will become basically like this, like A plus D, which is the second term. And if I will add one more D into it, I will get the third term. So it will become A plus 2D. Are you getting this? So basically, we can write AP like this also. A plus D, then A plus 2D, then A plus 3D. Are you getting this? No. Anybody has any doubt? Please ask me. Yes, Nayantara. What doubt you have? No? Okay. Reena, turn on your camera. Yes, Agatha, ask me.
The question is asking that we need to find the sum of three consecutive terms of an AP, but you are taking 4.
No, I am just explaining this how the A plus D, A plus 2D, and all this thing came.
Okay.
Reena Klein, did you understand? No. Okay. Now, the thing is, the sum of any, it is written. Sum of any three consecutive sum. So, like this is first term, second term, and third term. These are the consecutive terms. What is consecutive terms? Means one after one. So, like for example, this is the first place, this is second place, this is third place. If I will do the sum of that, it will become A plus D, and A plus 2D. Are you getting this? So, but the thing is, in this question, we will not take these three terms. Okay, now there's a trick. What's the trick is, the first term here I told is A na. This will be the second term in this question. Why? Because the before that, the first term, we can say, we will write before first term will be A minus T. A minus T. Okay, now we'll take some numericals to understand this concept. So for example, I'm writing with a green pen. This is not related to this question. Okay, so it's different. So for example, if I will write AP, like 4, 7, 11, and then 14, and no, not 11, 10. 10, and then 13, and then go on. So what is the first term in this case? It's 4. 4 is the first term. First term of an AP is 4. What is the second term? It's 7. And basically 4, if I will write 4 plus 3, which is A plus D is the second term. Got it? If I will say, Reena, what is the number before first term? What will you say? What will be the number before first term? Anybody can unmute and tell me what is the number before first term? Like this is the first term. What the number will come before it?
1.
1. How you got 1?
So,
So this is the first term. You took this is the first term, na? Like when you add plus D into it, you got the second term. Yeah. And this is the first term. When you will subtract the D from it, you will get the second term. Are you getting this? So it means that this can be written as A minus D. This can be written as A, and this can be written as A plus D. These are the 3 consecutive terms that we're gonna take. Are you with me? Abraham, did you understand? No. Ask me if you didn't understand. Okay. Miracle, Nayantara, Reena, did you understand? Reena, it is little bit tricky one, but whenever you get these types of question, you have to say like this. Now we are starting the answer, writing the answer. So you have to say it like this. Let no, not with this pen. Let the 3 consecutive sums be A, then A, sorry, not A. First is A minus D, second one is A, and the third one is A plus D. These are the 3 consecutive terms that we are going to take. Like this, I explain like this. Got it? Say yes or no? Okay. Now, how we will solve this? Now it is given that the sum of the 3 consecutive sum is 21. Means sum. Sum means adding. This is the first term plus. This is the second term plus. This is the third term. And if you will add these 3 terms, you will get answer as 21. Got it? Say yes or no? David, got it? Now, this minus D and this plus D will cut, and A plus A will become 3A. So 3A is equals to 21. A is equals to 21 upon 3. If you will cut it, you will get 7. So A is equals to 7. You got the first term as 7. Everyone got it? Abraham? You got it? No.
So
Now
I
their
have,
product. Yes, please.
shouldn't it be A and comma A plus D and comma A plus 2D? Why do you take the term before the first term?
The thing is, why I took this, the reason behind that is, if you will take this now, the equation become too complicated. Like here, what I am when I take this, so what I got now, like D and D variable cut, like it is simplified.
Okay.
If you will take A plus D and A plus 2D, in this we have two variable, A also and D also. And to solve both the variables, it's very hard and complicated. That is why we took A minus D, A and A plus D, so that D variable can easily cut or simplify, and only one variable will be there, and we got the answer also.
Okay.
Got it? No. Now basically we got the value of A, which is 7. Now we have to find the value of D and this D. So if you will minus D, you will get this term, and when you will plus D, you will get this term. Simple as that. Okay. Now in the above question, it is given the product is 231. The product is 231. So like what is the first term? The first term is A minus D. What is the second term? Second term is A. And what is the third term? It's A plus D. Okay. Now it is in the form of A minus B into A plus B. So what it will become? A square minus D square. Okay. Into A equals to 231. Now what is A? A is 7. So it becomes 7 square minus D square into 7 is equals to 231. This 7 will go and it will divide. So it will become 49 minus D square is equals to 231 divided by 7. If I will cut it, I will get answer as 3, 21 and then 3, 33. Okay. So minus D square is equals to 33 minus 49. So minus D square is equals to minus 16. This and this will cut. D is equals to root of 16. Then I will get D is equals to 4. So I got the value of D as 4 also. Okay. Now what is the first term then? What is the first term? It's A minus D, which we took. So A minus D means 7 minus 4, which is 3. Like this is the first term, which will be 3. This is the second term, which will be 7. And this will be the third term, which will be the 10. Everyone got this? Say yes or no. Nayantara. Reena. Ask me, Reena. Miracle. Abraham. Abraham, ask me, beta. What did you understand?
So in this sum song,
Hmm.
we're basically trying to find 3 consecutive terms of a term.
Yes. Yes. Yes, we are finding that only. So basically, the three terms which are consecutive sum is equals to 21, and which consecutive product is equals to 231. You didn't understand?
So I think I did.
Okay. Now this is the question. With this note, I believe we have completed this chapter. Agatha, did you understand? No.
Yeah.
Understood? So because Agatha got it, so we have to give the homework. So question number 2, then question number 5, and then question number 6. First part, second part, third part, and fourth part. So we will do this question. Like this is the homework. Okay, guys. So now you guys have 2 minutes break. We'll start our science class. Till then, bye, Nayantara. And tomorrow we'll start a new chapter named as quadratic equation. Okay. So till then, bye, Nayantara. Bye. Come back in 2 minutes quickly. Okay, guys, come back. We'll start our science class. So, in science class, I guess we were at we did some questions on the force. Yes. Wait a second. Okay, turn on the camera, everyone. So can you see the PDF, everyone? Joshua, is it now
Yes, I can
visible
see
now?
it.
What
See it, sir.
happened before? What
Before, sir,
happened
I
before?
lost my internet, sir.
Oh, okay. Okay. So now today we will learn about the Newton's third law of motion. Giddy, good morning.
Good morning, sir. Until last minute, I checked and the video was working, but now when I got into the call and started the video, it's not working.
You can't see the PDF. Is it like that?
No, my video is not.
Okay, your video is not working. Okay, it's okay. It's okay. So now today we will do Newton's third law. Okay. So those who can turn on the camera, Nina, David, Abraham, please. Okay. So what is Newton's third law says? Newton's third law says that if somebody slaps you, that you have to slap it back. Means every action has an equal and opposite reaction. Is it correct? Huh? Is it correct? Like Bible says that if somebody slaps you, then give your second cheek also. But Newton's third law says that if somebody slaps you, then give a different tight slap. No, it's not like that. So basically, what is Newton's third law? Okay, so I guess Saturday I went to OTC, like water park, uh, to have some good time in water park, and I observed that like there's a pool called as lazy pool, in which you have to just sit on the tube, and the tube like the water is flowing slowly, and you will go with the water. That is what's called a lazy pool. Okay, so basically, when I was trying to sit on that tube, okay, I'm putting my pressure on the tube so that I can sit. The tube is pressing me to go out. So it is like that. When I'm pressing the on the tube, okay, the tube is putting me pressure again on me so that I can fall. So basically, this is called as Newton's third law of motion, in which I am giving an action to the tube to sit on it, and the tube is putting like giving me reaction of it. And the lazy pool is to only to sit, to become a lazy person. But in that pool, I struggle a lot. Like it is not become lazy for me. It is become like you are doing a hard work on it to sit on the tube. Then I got some trick to get sit on it, but like in starting, I was literally struggling. If somebody shoot that video, then I will become viral in just 2 minutes because I'm not able to sit it. There's a trick for that. I was trying, I'm jumping, but the thing is the tube itself is giving me to high jump. So it was a great experience. But yeah, so what is the Newton's third law says? Newton's third law says that if you are putting an action on an object, the object will give a reaction on it. So I'll come to one by one on every student. You guys think what uh, like one example of Newton's third law in your day-to-day life. So we'll start with Abraham. Yes, Abraham. What is an example that you see in your surroundings of Newton's third law?
So can you just repeat, sir?
Yeah. What is the one? Give me one example of Newton's third law. I explain Newton's third law that every action, like if you are putting an action on an object, the object will give a reaction on it.
Okay,
So
sir.
any example?
If somebody slaps you,
Yeah.
their
Huh.
hand, then they also get the thing hurt is because the kinetic energy travels through you and then bounces back on them.
Okay. Means somebody punch you. Huh?
So they also get slapped on their hand then.
Um, that is kind of, but any other you think?
So if I throw a marble at a wall, the marble will go to the wall and then it'll bounce back.
Oh. Yeah, so the wall is pushing the force to the marble so the marble can go off. Like, is it like that? Yes. So basically, it is like that. This is the correct example of Newton's third law, in which if you will throw a marble with a great force to the wall will push it back towards you. Simple as that. Yes, Agatha. Any other example of Newton's third law?
When you drink water, when you drink
What?
water in a bottle, when you drink water in a bottle,
Uh-huh.
I don't forgot what I said. Yeah, like in a car, if you like if you push a car, have something like a bit heavy, you'll also feel something a force or
Yeah. So that is also an example in which you are pushing a heavy object like a car. So if you are like, um, um, if you are like, if you are like a stick, then instead of pushing, you will get a slide. You will, yeah, you are pushing it, but you are not able to push it, but you are getting a slide in a backward direction. It means the car is also putting a force on you so that you are going in a backward direction. So this is basically third law of motion, in which when we react on it on an object, the object will react on it, and it's not about only about us. For example, if I will blow a balloon, okay, if I will blow a balloon, and if I will release it, then you know what will happen? The balloon gas will come out
in one direction, and the balloon will fly away in the opposite direction.
because of air. The balloon is putting a force on the air, and the air is helping that to go in like this, like a rocket also. If rocket is there, what rocket is like? How rocket goes into the space? Abraham favorite topic. How rocket goes into the space? Rocket, like when rocket, like three, like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and brrr. So all the air, gases, or combustion will go in downward direction. And because that force which rocket put on the earth gives that force to the rocket so that rocket can go in upward direction. Simple as that. Everyone got this? Huh? So this is basically the Newton's third law. Any more examples of Newton's third law? Yeah. Somebody
Even
saying.
when we are walking, our foot pushes the ground backward and the ground pushes forward.
Perfect. That's why we are able to walk. Why we are not able to walk on ice? It's basically the another reason is friction only. But the thing is, you are able to walk because means you are pushing the earth back, and the earth is pushing on you. So it is on different two objects. It's not only on one object. It's on two objects. You are pushing on wall, the wall is pushing on. You are pushing the earth, earth is pushing on. So Newton's third law applied not only one object, it applied on two objects. Are you with me, guys? Say yes or no.
Yes, sir.
Yeah.
Can you
So
Newton's
yeah,
third law one more time? Like my net was little.
yeah. So Newton's third law is simple as that. That when you do a reaction to the object, when you put a force on it, the object will also put a force on it. Simple as that. That is the Newton's third. So we'll read one by one. Here we have. So yeah, this is also one of the great example that we used to give. Like for example, the girl was on the boat. Now when the girl will jump to the land, obviously it will put a force on the boat, so that boat will go in that direction and girl will go in that direction. So this is an opposite direction and equal forces there. Got it, Nidhi? Okay, so it is always equal and opposite force. Equal means if you will put a force on, if you put a force on the boat will also put a force, so that boat will go in that direction and you will go in that direction. So this is opposite direction and equal forces are there. Reena, did you understand? No. Okay, so we'll read it. Who will read it? Reena will read. Yes, Reena, can you read this? You're mute.
Yeah. Newton's third law of motion. You must have noticed that when a rubber balloon filled with air is released, the balloon moves opposite to the direction of the air coming out of it. Why does the balloon move in direction opposite to the direction in which the air escapes? Let us find out. You must have also noticed that when you jump from a boat to the riverbank, the boat moves in the backward direction. Why does this happen? While jumping out of the boat, your foot exerts a backward force on the boat. This force is called action. At the same time, a force is exerted by the boat on your foot, which makes you move forward. This force is known as reaction. Remember that two bodies and two forces are involved in this problem. You pushed the boat backward and the boat pushes you forward. These two forces are equal in magnitude but opposite in direction.
Yeah. Remember this thing, these forces are equal in magnitude but opposite in direction. Like if you are putting a force on the boat will go in backward direction, but you will go in forward direction. So the opposite direction is there, but in a equal amount of force. If you will put a 2 Newton force on the boat will put a 2 Newton force on it. Are you getting this, Nidhi? No. Okay. So now we'll read the next part. Now, in this case, in this case, will they able to push the car because they are in the car and they are pushing it? Will they able to push that?
No.
No. Why? What's the reason behind it?
Because the force which is pushing the car forward, and like when they are pushing the car forward, they also push the car backward at the same time because their feet are touching the car. Like the same
The
way for the
feet,
boat.
yeah, okay. But the thing is here, the action and reaction is always on two bodies. Is it correct? Like here, when we push a car standing outside of the car, so what happens? I am putting a force on the earth. Earth is putting a force on me so that I can push a car. Simple as that. But when I'm in the car and when I'm pushing it, do you know what happens? I am putting a force on car to push it. The car is pushing me like because I'm able to move in the car, but the force which I need to give to the car, it's not there because it's not on the different body. It's on the same body which is on the car. The force is on the car and the car the reaction force is also on the car. Are you getting this? No. The action force which is mine, it's on the car. And the reaction force is also in the car, which is on the same body. That is why the car is not able to move. The third law of motion works only when the force is interchangeable. Means we cannot say which force out of the two forces in the force of action and which one of the force of the reaction. Which is the reaction one? The reaction one is not there. Action and reaction always act on two bodies, not on only one body. Here it is only on the car. Okay. The force of appears so long the force of action acts, therefore the force are simultaneously. Like if I am putting a force on this table, for example, if I'm on the table, I will not able to move it. Why? Because I am putting the force on table so that table can move. So the action and reaction force should be on the table. It's not possible. But if I am on the earth and if I will push it, then you know what will happen. I am putting a force on the earth. The earth is putting force on me so that I can move a table. Two different bodies are there. Abraham, did you understand? Nidhi, Reena, Miracle, did you understand? No. Hmm?
Yes, I understand.
Okay.
Yeah.
Yeah. So, Joshua, can you read this?
Where, sir?
Yeah, here.
Let us consider the balloon problem again. In this case, the air coming out of the balloon action exerts a force of reaction on the balloon, and this force pushes the balloon backwards. That's the reaction. Newton, in his third law of motion, stated a relation between action and reaction. According to the law, to every action there's an equal and opposite reaction. The action and reaction act on two different bodies of action and reaction on the same body. They will constitute a balanced force, and the body will not move.
Underline this. Underline this. This is an important line. Okay. According to this law, every action there is an equal and opposite reaction. The action and reaction act on two different bodies, not on the same body. If they will do on the same body, they will constitute the balanced force and the body will not move. So if they will ask you this question that if you will put an action and reaction on the same body, why the body will not move? Here is the answer. Are you with me, Abraham? David? Miracle? Got it, Nidhi? Okay. Now read the next part. Joshua. Okay.
Look at figure point 10.11 and find out the action and reaction forces and try to analyze whether it's actually move or not.
Yeah, read this.
There are two significant features in the third law of motion. We cannot say which force out of the two forces is the force of reaction, which is one force of action, sorry, and which one is the force of reaction. They are interchangeable. Action and reaction always act on two different bodies. The force of reaction appears so long as the force of action acts. Therefore, these two forces are simulation. Remember, it is not.
So, like if I am putting a force on the earth for a long time, so for the long time, the earth will also give the reaction of it. Okay. If I will put a less force or for a short time, if I will put a force, okay, so the earth will give me the less reaction. So action and reaction is on simultaneously. For 2 seconds, if you are putting a force on it, the same reaction you will get for a 2 seconds. Are you with me, guys? Okay, and it's not delay. It's simultaneously. Good. Yes, read the next part. Now, this is the important line. So please underline it if you have book, because they can ask you what are the three significant features of third law of motion. These are the three significant features. Abraham, you got the book?
No, so not yet.
Okay, you didn't print it out also?
No, sir, not yet. So I don't know where to get the book printed from. Like, where's the link?
Okay. I'll send you the link today. Okay.
Okay, sir. Thank you.
Okay. Okay. So now we'll read this. Who will read this? Agatha will read. Yes.
Remember, it is not necessary that the two bodies amongst which the force of action reaction are in contact. They may be quite far from each other. For example, attraction or repulsion between two magnets can take place even without being contact.
Yeah. So it's not necessary that they should be in contact. Like when you will put a north pole and south pole of the magnet near to each other, they will stick automatically. Like you have to bring them to some distance, and after that they will stick automatically. You don't need to bring it forward also. So this is basically the example of non-contact third law of motion. Okay. Yeah. Read the next part, please. Yes, I got it.
Do you know that action reaction forces enable us to walk on the surface of the earth? Let us see how. While walking on the ground, we push the ground with our foot in the backward direction. This is the force of action. In return, the ground exerts an equal force of reaction on our foot in the forward direction. The force that actually makes us walk is the forward direction in this reaction force. During swimming, we push the water in the backward direction to this force that pushes us forward.
Yeah. So
It
who
may
knows
be
swimming?
interesting for you to know that rock.
Who knows swimming?
My brother, sir.
Yeah. Even I know swimming. I know swimming to get drawn. Yeah. So I mean, just kidding. So swimming, like basically, if you know swimming, so when swimming, you have to push the object in, like push the water in backward direction. Okay, it's like that. Yet you are pushing the water in backward direction, and like this. And when you push a water in backward direction, the water itself will push you in forward direction so that you can. It's a simple. Okay, like I'm giving you swimming tips also. When you're going for a swimming, just put your leg like and just like a duck, you have to put your leg like this. Okay, so that you can get the momentum and the speed, and with your hands push it in the backward direction. Simple as that. You will. Are you getting this? So, swimming is not so much hard. Okay, I'm in master in it. Like from my childhood time, I was master in it. So pushing is not that much. Got it? Yes or no? Yeah. Read this.
I'm not able to move the PDF. When I move it, it's drawing lines.
You're not able to move the PDF.
Yeah, when I move it, it's drawing the lines, as you can see.
Okay. Just give me a second. Okay. Now you're able to do it?
Yeah. Able to do it. Thank you, sir.
Okay. Now this is a new topic called as conservation of momentum. So I told you about momentum, just for a revision. Momentum is not only about the velocity, it's mass also. Like if you get hit with a toy car, you will not get any like it's just a like normal scratch you will get. But if you will get hit by a truck with the same speed, then you will definitely will have a lunch with Jesus because the truck is heavy and the same velocity is there. When it will hit you, bones will fracture, uh, everyone is damaged. Okay, so basically, conservation of momentum says that the momentum before collision and after collision is same. Now we will understand this. This is very important topic, so please pay attention. So for example, here are two balls are there. This is one ball and this is another ball. Two balls. Okay, now listen everyone. Two ball says that this ball has okay. Okay, this we have two balls here. This is mass A and this is mass B. We have two balls, mass A and mass B ball. Okay. Now I will shift this. Okay. Now listen, guys. Now, for example, this ball is moving in this direction, and this ball is also moving in this direction. In this direction. Okay. Now, basically, the speed of the mass A ball, it's high. It is high. Then you know what will happen? Do you know what will happen? Like, for example, because the velocity here it is high, like this is VA, this is VB. So in this case, it is given that VA is more than VB. So obviously, the velocity of A ball is high than velocity of B ball. So the A ball will come closer to the B ball, like this. Are you with me? And after some time, what will happen? Who will tell me? Joshua, after some time, what will happen in this case?
Pardon, sir?
Tell me. After some times, what will happen in this case?
It will continue going.
Huh?
Will continue going in straight line.
They are going in straight line, and like because this
Will
ball
continue.
has a great velocity, it will have great velocity. So after some time, what will happen? It will collide. They will what? They will collide, na?
M has a greater
Yes or no?
velocity.
Yeah, it has greater velocity. So for example, these are the two balls. They are moving like this. But because this has more velocity, so it will come and it will collide like this. Okay. So it's gonna be look like this. It will collide like this.
Yes, sir.
So basically we have here two balls. I will explain this here. We have two balls. This one MA and MP. Okay. Now it has VA velocity and it has VB velocity. Did you understand? Yes or no? Rina, did you understand? No, you didn't understand. Now it is given that the velocity of A means the first ball has good velocity than the second ball. Okay, this VA is more than VB. Are you with me? David, Nidhi, Agatha, Abraham, did you understand?
So which one has greater velocity?
This VA, the first ball. Okay, so the first ball has greater velocity than the second ball. So the first ball is traveling fast than the second ball. So after some time, what will happen? The first ball will collide with the second ball and their velocity will change. Are you getting this, Miracle? Joshua, got it? Say yes or no?
So,
Yeah.
so is the second ball moving?
Yeah, its second ball is moving, but the velocity is less. For example, can you see my camera? It is like this. The second ball is moving, but slowly, and the first ball is moving fastly. So it hit the ball like this. Got it? Okay. So here, because
Not able to see your screen.
my camera, not screen. Like this is
Yeah,
B ball.
to see the
Okay, maybe network issue. So basically, what I'm trying to say, the
but I can
second
see
ball
you.
VB. Yeah. So the second ball has less velocity than the first ball. The first ball is moving fast, and after some time, it will get stick to the second ball like this. Got it? Yes or no? Hmm? So this says that we will we will do the derivation tomorrow, but today we'll understand this that momentum before collision is equals to momentum after collision. Momentum before collision is equals to momentum after collision. Means the ball which was moving before collision, their momentum and the after momentum collision, they both are same. This is basically the law is saying conservation law of momentum. The momentum remain conserved. The momentum before collision is equals to the momentum after collision. Are you with me?
Sir,
Yes.
so VA and VB's momentum is still the same after and before collision.
Yeah, before collision and after collision, it will be same. So it's like this. Okay, it's like this. Obviously, if this ball, if the first ball will hit the second ball, so second ball speed will increase, na? Like it will go in forward direction. Are you with me?
Now then the
No.
velocity will increase, right? And then the
So
momentum.
velocity of mass will remain same. Mass will not change, no. But what will happen? The velocity of VB now increase. It become more than VA. Are you with me? It's like this. If the bowling ball is there in front of me, I put another bowling ball, then this will have good speed. It will give the speed to the first ball, and the first ball will move in fast speed. Are you with me?
So now the VB ball has the momentum of VA ball and VA has the momentum of VB.
Yeah, and the velocity VB will be more than VA in this case. So it remain conserved. The velocity remain conserved. Yes, Nidhi.
So VB and final answer, like if this question is there, so final V equals VA. Is it like?
Yeah. So before it was VA is greater than VB, but after collision, now VB is greater than VA.
Not
Got it?
so not equal.
No, they won't be equal.
Not
Like
equal.
for example,
Okay.
no, they won't be equal because now the velocity is transferred to the second ball, VB, so that it can move forward in fast direction. In fast speed.
Okay. If there is if that and VB they both are velocity is equal, so the answer will be VB equals V.
If they both have same velocity, they will never collide. Because, for example, this ball is moving with this speed and the same ball is moving with this speed, so they will maintain their distance between them. They will never collide. It should be VA should be greater than VB, then only the collision can happen. Got it?
So it can be like we just take a VB, right? There can be any other.
Yeah. So always VA should be greater than VB so that collision can happen. And now VB is greater than VA. We'll do the more deeper thing in tomorrow so that we can understand more clearly. Okay.
Sir, I have one more question.
Mm.
It's not regarding to this class. It was yesterday's class homework. I didn't understand number 1.
You didn't understand the number 1?
10 point. No.
You mean Fridays?
10.1. Question number 10.1.
Here, this one.
Yeah, I didn't understand this.
So basically, here it is, force is given and mass is given. We have to find the acceleration. So we have the formula, force is equals to mass into acceleration. Force is given, which is 15. Mass is given, which is 3 into acceleration, which we don't know. And this 3 will go and it will divide. So it will become 15 divided by 3 is equals to acceleration. And we got acceleration is 5 meter per second square.
Yeah, so my question is, how do we know it's
How do we?
like we're dividing 15n by 3 kg.
So basically 15 is Newton. 15 Newton is force, na? Like Newton is given, which is always force. And kg is given, which is
Yeah, so
mass.
the final answer, it should there kg and that.
The final answer, it's very cracking sound. Yeah.
And the final answer, yeah, in the final it's 5m s minus 2. So
Yeah.
shouldn't we write kg? So
No, kg won't be there. Basically, if I will write like this, we know that force is equals to mass into acceleration. Mass unit is kg and
yeah,
acceleration is meter per second square. Okay. Now in this case, here I wrote Newton. Na? So instead of Newton, can I write like this? 15 kg meter per second square, because it is equals to Newton also upon 3 kg. So kg
yeah.
and kg will also cut. Na? So what will remain there? Only meter per second square.
Okay.
That
Yeah,
is why
okay,
it is
I
only
got
meter
it.
per second. Okay. Okay,
Yeah,
guys. So
I'll
we'll end
try
this
that one
class.
more time.
Okay. Okay, guys. So we'll end this class. I hope you have enjoyed the class. Till then, bye. Have a nice day. Signing off, Berkshire. Bye.
Bye, sir. Thank you, sir. Bye. Maybe bye. Bye.
Bye,
Agatha.
sir.
Bye.
Thank you.
Bye bye.
Bye. Bye. Bye. Bye.